So one of the problems you're going to see in your homework on WebAssign asks you to just write out what this is in words. Log base 4 of 16. That's the way this is read. So you have a little drop-down menu or a little fill in the blank. I think it's drop-down menu. Log base 4 of 16. So I think the words you're going to have to put in will be the base and the of. Now, a good follow-up question is, what is the log base 4 of 16? And the idea is that what you're going to do is look at the base and ask yourself, what power of the base gives me the 16 there? 4 to what power? Can anyone tell me?
To the second.
4 to the second power. Excellent. So this is equivalent to 4 to the second power equals 16. Those are two different ways to write an equivalent expression. In general, it looks like this. And this is probably something that I would have written down for myself for an exam. In fact, in an in-class exam, what I suggest is that people write this on the top of their paper. Because in an in-class exam, you're not going to be able to have formula sheets and this kind of stuff and the other, no notes. I suggest you write this down right at the top of your paper. It's called a memory dump, so that you've got this, so that later on when the instructor says, oh, 10 minutes left, you know, panic and forget it. It's already written down. It's a good test-taking technique. Now, this and this are interchangeable. That's what I mean by this bidirectional arrow, is that they're equivalent to each other. And a lot of the problems that you're going to face are going to be stuff like this, where you're given an equation in one form or the other and asked to rewrite it. So what I suggested is you do something like this. You start out with the base. You go over here. So it's the base raised to this power equals that. And I always think of it like a tornado symbol on a weather map. You know, this little whirlwind here. And equivalently, this should be 8 to the negative 3 power equals 1 over 512. The nice thing about it here is that you can actually check that pretty easily using, say, a graphing calculator. I should be able to do 8 to the negative 3 and get 1 over 512. And let's see that that's true. So let me just clear out a bunch of stuff here. Eight raised to negative 3. Doesn't look like 1 over 512. But if you hit the math key and then press enter twice, it'll turn that into a nice fraction. So 1 over 512. Yay, looks good. We okay with that first example?
Is there a way to do math enter on like Desmos, or does it just give you the fraction?
No, I don't think so, not on Desmos. But here's what you could do on Desmos. So that's a great question. It's like, well, wait a minute. If I wanted to confirm it on Desmos, what could I do? First of all, let me go to a different Desmos page than usual. Desmos, and I think it's scientific. Yeah, there you go. So desmos.com/scientific will just open up a calculator. I think, I'm hoping. Yeah, there you go. So I can do 8 raised to the, I guess I got to use this one, negative 3. Enter. And we'll do, I'm not sure what this does. And then I can do 1 divided by 512 and see that I get the same decimal value. So that's kind of a workaround there. Oh, you know what? Let's just do this. Let me click this. Oh, there's your answer. How about that? I figured it out for you. If you click that, then you got a nice fraction. Beautiful, eh?
Yeah.
So the answer is yes, you can do it in Desmos. That's cool. That's really cool. Thanks for helping me discover that. Okay, let's try one in kind of the opposite direction. We'll start out with something with exponents and then see if we can't write it with logarithms. So my example here is going to be 3 to the negative fifth equals 1 over 243. So I want to write that using logarithms. Now, if you've got this written down on your paper or at the top of your test, the easy thing to do then is just to draw some associations. Say, all right, that has to be A. What's my X going to be? That has to be X, and that has to be Y. So when it comes to plugging things in over here, I want the log base A. Well, what's A for me over here? What was A?
3.
3. Thank you. So log base 3 of X. Someone else for the X. What's X going to be in this case?
1 over 243.
1 over 243 equals Y. Well, what number haven't I used? What's Y equal to in this case?
-5.
-5. And that's it. So we started out here with an expression using exponents, and I wrote it using logarithms. Perfect. You should expect to be able to go back and forth. Okay with that one? Now, one of the problems that you might see in your homework someplace basically really requires you to know how to go back and forth like this. So I'm going to practice it one more time. Let's do log base 64 of X equals -1/2. And the thing is to solve for X. Well, to start this, start by rewriting this using exponents. So see in your mind if you can't do that. Now I would suggest you do what I did here. It's always the base to this power equals this. See if you can't rewrite it using that little pattern. The base, the power on the right side equals it's called the argument of the function if you want a fancy term there. So what are you going to get? Anyone want to share with me? What to what power equals what?
64 to the -1/2 equals X.
Beautiful, beautiful. 64 to the -1/2 equals X. So let me share my screen with you and clean up a little bit of a typo on my part. Yeah, I can't do it very easily. So 64 to the -1/2 equals X. Now 64 or anything to a negative power, I can rewrite that as a positive exponent if I put it in the denominator. So let me write it like that. This is bothering me here. Sorry, it's my OCD there coming through. But let's see, does anyone remember a different way I can write something to the 1/2 power?
You square it?
Root of 64.
You take the square root of it?
Yeah, there we go. I think a couple of you came up with that. Let's take the square root of that. So what's the square root of 64?
8.
8. So the answer, when it's all said and done, is 1 over 8. Oh, okay. Nice. In fact, log base 64 of 1 over 8 equals -1/2. If you wanted to, you could raise 64 to -1 over 1/2 and just check it. I mean, you can check it directly, but if I do 64 raised to the negative, I'm going to do 0.5 here. And then click this button. And there you go. 1/8. Voila. Double checks your work. That's really cool. How are we looking with that one? Doing okay? I know there's one like that in your homework. Now, another thing that you're going to see in your homework is going to ask you to graph things here. So for instance, they're going to ask you to graph, say, f of x equals log base 9 of x. And that's a little bit of a challenge. I'll give you a couple ways to work it, 2 different ways to work it. It's going to depend on you as to what you like. It really doesn't matter to me which one you do. Let's start with f of x equals log base 9 of x. Now for convenience, I'm just going to write that as y equals log base 9 of x. Now, if you can remember this, there's a way that you can draw this directly on, plug this in directly into Desmos. But before I get there, let me see. Let me write log base 9 of x equals y. Just turning it around. Try and write this with exponents. So practice that idea of converting something to exponents one more time. And I just rewrote it here because now it's hopefully a little bit more familiar. It looks more like in the form that we practiced. What would be the equivalent expression using exponents?
Would it be 9 to the power of y equals x?
Excellent. Thank you, Z. 9 to the power of y equals x. So let's write that down. 9 to the y power equals x. So cool. Let's work our way over to Desmos now and to the graphs. Let me just start all over here. You can plug this in directly if you wanted to graph, say, log base 9 of x, if you can remember the following sequence. So click the keypad here. That'll bring up this. Then you got to go over to functions. Once you open up functions, you got to click miscellaneous. Once you click miscellaneous, it's down here. That's the one you want. So that puts a little subscript down here. You can type in the base, log base 9 of x. And generally speaking, I like to put in the y. It's understood by Desmos that you have y equals that, but I like to make it explicit. So there you go. That's one way you can do this. But there's another cool way that we can do it that's kind of fun because it relies on the fact that these 2 expressions mean the same thing. And the nice thing about Desmos is you don't have to have y solved for. With your graphing calculator, you couldn't do this. With graphing calculator, you'd have to solve for y. But with Desmos, I can type in 9 to the y equals x. So let's do that. 9 raised to the y power equals x. And wow, hey, that's cool. I got the graph. How nice. Now be careful you don't type in the wrong function. If you typed in y equals 9 to the x, now that's the inverse of this. Remember the exponential function, which is what this is, and the log function, which is what this is, are inverses of each other. Do you remember the relationship about those 2 functions? They're symmetric around this line, y equals x. So instead of a point at 0, 1, you have a point at 1, 0. oops, instead of getting close to the x-axis as you go out towards negative infinity, you get close to the y-axis as it goes towards negative infinity. So nice. They're mirror images of each other. But the important thing that you should be able to see is there's a couple ways that you can come up with the graph of this function. Just out of curiosity, which one do you prefer? The first way, finding the notation here in Desmos, or just using the inverse? Second way. First or second, doesn't matter to me, just curious.
Second, I like the second way.
Second way, okay. My morning class was the same way. They like the second way better. So, but whatever works for you. I mean, there's no real right or wrong answer there. All right, are we looking good there? I think that's pretty much it. The one last reminder is, like I just said, is that the function for the log and the function for the exponential functions, they're inverses of each other. And that's an idea that's present throughout all our work in sections 11.4 and 11.5 and 11.6. So any last minute comments, thoughts, or questions? All right, let me put you, yes, question?
Sorry. Can we ask about the topic that you were going to discuss with us regarding the series of classes following this one?
Oh, yeah, what to follow up with this class? Yeah, we should talk about that, but let me do that after a little bit of a break.